This video is a key to Learning Objective 8 practice problems. Our starting material has a nitro group and a carbonyl group, a ketone, attached to the aromatic ring. So we're going to look at a variety of different ways to reduce one or both of those functional groups. First, we'll start with the hydrogen and palladium. When that happens, we reduce the nitro group to an NH2 group. We reduce the carbonyl to a methylene group. Methylene is CH2 group. The next reagent we're going to look at is lithium aluminum hydride, followed by aqueous acid workup. That reduces both functional groups, but it gives different products. The nitro group is still reduced to an amino group, same thing, but the ketone is reduced to an alcohol instead of to a methylene. And then the final reducing agent is tin chloride with HCl. When we reduce that one, when we use that reducing agent, it reduces the nitro to an NH2, and it doesn't do anything to the ketone. So if you need to reduce a nitro group without reducing other functional groups that are in the same molecule, metals with HCl are a better way to go. Now we'll look at the next set of problems that are farther down on this graphic. Our starting material is in the middle. It has a T-butyl group, and it has a ring that's attached in two places to the aromatic ring to make a cyclohexane ring. On the left, we are reacting it with NBS and light. We could also have used a peroxide initiator. The T-butyl group doesn't react with the NBS because we need a benzylic hydrogen, and the benzylic carbon is occupied with 3 methyl groups attached. But both of the carbons directly attached to the aromatic ring are benzylic carbons, and so they both add bromines. You might notice I have some weird stereochemistry stuff going on. I drew wiggly bonds, and that means I have a mixture of stereoisomers. The other reaction on the other side of the screen has... Whoa! Has oxidation for the aromatic, for the side chains. Potassium permanganate leads to the 2 side chains in the 6-member ring to being oxidized, and it does nothing to the T-butyl group. And as you saw, I fixed the aromatic ring to make sure that it's still aromatic. Okay, new set of reactants. The nitro group and isopropyl group. First, we're going to react them with potassium permanganate. That only reacts the isopropyl group, and it does side chain oxidation, taking away all but the benzylic carbon, where we get a carboxylic acid. Nothing happens to the nitro group when we oxidize it. Next, we'll go clockwise around this chain. We are going to react our starting material with hydrogen and palladium. That reduces the nitro group and doesn't do anything to the isopropyl group. So the nitro group becomes an NH2 group. The next reagent is lithium aluminum hydride, followed by aqueous acid workup. That reduces the nitro group to an NH2 group and does nothing to the isopropyl group. The next reagent is tin chloride with HCl. That also reduces the nitro group. So when you want to reduce a nitro group, you have choices. The next set of reactions happen with a molecule that has 3 different alkyl substituents on the aromatic ring. First, we will look at NBS reacting with this starting material. Oh, I lied. First, we'll look at side chain oxidation. In this case, all three of the side chains are oxidized because they all have hydrogens on the benzylic carbons. And last, we will look at NBS and light, and that gives us bromine in all three benzylic positions, and we're going to get a mixture of stereoisomers on the left side of the ring because there are new chiral carbons that are formed. Okay, last question on this handout is about styrene. We're going to propose a method to make styrene using benzene, and the question points out that at least one of the reactions we need to use is from Chem 241. Here is the structure of benzene, which is our starting material. We're doing this backwards, so we're doing the final reaction first. We're going to take a bromine and eliminate it to give the styrene. You may remember from Chem 241 that elimination of alkyl halides is carried out with base. We probably also have an alcohol solvent there. Now we need to make this brominated compound. This will use a reaction that actually belongs to LO8. The other reactions in this synthesis belong to other parts of the course. NBS with peroxide from ethylbenzene is a good way to put a bromine in the benzylic position. Now we need to make ethylbenzene from benzene. We can do that with Friedel-Crafts alkylation. We put the ethyl group on aluminum chloride. And now we're done.